Let's get going. Okay, so what we're talking about here is I had some demos to do today of the things that I tried to get done over the last 2 weeks since last time we spoke. And so I have attempted 3 things. And so let's go over them. So first off with the, there we are. First off with the Gamma, I have tried the Firewalker approach, which we saw last time. And I also tried to do something really cool. I tried to create an infrared synchronization process so that all the shoes could all be synchronized all at the same time. And I have picked up a microphone to take the room from the noise from the room, and so we can pulse the equalizers into the shoe. And I have some of it working. The main problem is I can't get a stable message out of the Arduino yet, but I have got the receiver side working on the in Python. It's actually the C code that's not working, and so we'll go over that in a minute. So let's go. I have the hardware for the Flame, and I just have to build it on the shoe. We'll do that. I've got the equipment wired acquired for everything for the for that, including some hardware. I will get this out for the demo. And then our problem is the receiver works, but the remote, effectively the remote doesn't work. And then on the other side, I also built for my friend Jag some analog solutions.
Thank you.
And they're running right over here. Let's go over that. So I found that the vibration switch is not very interesting, as it only blinks the LEDs. It doesn't do anything, so we need a different logic for that. And we found that the blinking LEDs, which I can give you some of, actually are a switch. They're cutting the whole circuit. So they turn off all the LEDs on the circuit that you have. And so you can see I have 3, and we'll do that for the demo, 3 bound. And then the other thing I did is I picked up from Lady Ada. Where'd they go? Sorry, I lost it. Oh, here it is. Actually, I snaked that back from Spark Fun. This cool little tiny microphone that should be able to drive something. And so what I want to do is be able to have the sound for the analog be able to drive some of the LEDs. And this is not working. It just does not have the oomph to do it, but we'll talk about some possibilities for that. So I'm looking like I might need an amp, or I might be able to get away with just a transistor switching back and forth. And then also I could, since it's analog, we could build a filter and filter the different frequencies, so we could send different frequencies to different LEDs and create an equalizer without any microprocessors.
Can I say something?
Huh?
Can I say something?
Yes.
This is very cool.
Yeah. So we'll see if we can do that. And I have some demos of the breadboard for that. I have breadboarded out the transmitter, and we have an actual working receiver over here that is actually in Python. And so all that's good. So must be time to
hey, come on in. Welcome back.
Yeah, time to demo some things, I think.
Right?
Yeah.
Okay, we're going to demo some things first. So let's start with the easiest one. This is the standard Firewalker, and you can see that it's longer than it was before, and it goes. And the more you rattle it, the more pixels it starts to go down on. And so the more you rattle it, the more it goes. I'm not really happy with the software up here. The flame marking software looks a little, well, uninteresting to me. But
to you, I think it looks cool.
And so I wanted to do a little more. And so working, you can see when I shake, this is running with the explosive LiPo battery, so that you can wear a bomb on your foot, because that's what all the cool kids do. And so I have this working, and then we'll be wrapping this around the shoe, a fine Nike product.
Can you wear that?
This is my wife can wear this
Oh,
shoe.
okay.
My wife will be it's going to be the demo for these.
Sure.
Yeah. Yeah, she donated the shoes.
Okay.
And then you can see also that I had to solder on these god-awful little tiny pixel things. And I will tell you that I broke those wires off 3 times. And so I didn't particularly look at. I looked at the demo of them soldering, and I noticed she was looking unhappy also. So I'm kind of the opinion that really sucked. But they'll go over the bend of the shoe so that you don't bend the NeoPixels strips. And so we have the NeoPixels would be glued on the shoe like this, you know, and they'll start bouncing around. And when you're walking, they'll bounce, you know, they'll start, you know, flopping around. And then we'll have I'm thinking of putting the NeoPixel right here and the battery pack on the laces. And so.
Sorry.
Yeah.
So I was wondering if the light is actually changing because of the sensor.
There's a vibration sensor that I soldered into the gamma that is working. So,
Okay.
and we have a hand around version of that I just put away that we used last time. But that's so that is the one out of the book, let's say. The codes from them. I did change the code. I made it refresh immediately. I didn't care for the wait for it to get nice, and I just sent crap into it.
What glue are you using for?
The software's got a
What glue are you thinking of using for that?
Oh, I was just going to use a standard epoxy and put it on there. Now they use some kind of complicated rubber cement in their video, and they wipe it off and all of that. And I was, by the way, if my super glue had not been used up by the guy that lived with us, it would already be on the shoe. Yes, Corwin. So wherever you are, Corwin, you used up all of my CA without telling me. so anyways. And I also dragged the plastic over top of the part that I soldered. You can see right here, and I will add some more of the little plastic on the back here. So, or I'll cut those two off and not care because there's a lot of light. All right. So that was the Flame Walker one. All right. So then let's talk about the synchronized shoe project. And so if you remember, I brought this piece of craziness over there. Okay, this piece of craziness last time. And what you'll notice is that I have wired on an infrared detecting diode onto it. Costs about $1.10 for one of these, actually. And then I can, my program ended. And my program ended while we were talking. So if you can hold that for me. Sure. I will find my way and restart the program and move. Yes.
If you want.
Yeah. So we're going to restart.
See here, Jag.
What's this one?
That's his desktop.
Yeah.
Oh, you watched it already. Yeah.
Right. And so.
I want to sit here. I want to be
In the middle.
in the thick of it.
All right. So let's see if we can load that code back up. And this is the serial. Okay, maybe it is running. I didn't think it is. If the light's running like that, usually means it's not running. So we're going to use a simple Microsoft approach.
Excuse me?
Yes, we will.
Are you against Microsoft?
No, but I do notice I have to restart the products all the time.
You have to reboot.
It'll be a lot more fun with Azure in the future. Okay, yes, there we are. Now we're ready. Okay. So you will notice that when I bounce the LED, that the thing flashes. That's because if you bounce an LED, an IR LED, it thinks it heard a signal.
Oh, okay.
Well, I have a remote, and see,
Wow, cool.
and so I can cause it to flash. We need to actually turn this one off for a minute because we're going to point this away. Can you point that way for me? Yeah. So that will stop interfering. And you'll see that I can do this. Now, if I bring up the serial here, it will tell me what is the actual codes coming from the remote.
Nice.
And so I can now run this thing. Now, what I'm having trouble with is I'm having trouble decoding the remote because all the values are approximate pulses, and so you have to get a 20 or 30% match. And so that's been aggravating as I'm used to having the right answer. And you'll notice that some of these come up on 67. 67 is the right answer. Everything else is just getting lost in translation. And so, but you can see that I flash the NeoPixel every time I hear from it. So this was my idea. Now, if I could just put this little thing onto the shoe, plug it into that, then I could use a remote control and run the shoe. And that's kind of interesting.
What's the effect 224?
Well, I'm headed there.
Okay.
So that would be kind of cool. And then I have all these other buttons. I could actually program all of them separately and have different effects on each button. And you can see it reads all the buttons.
Nice.
And that would be really interesting, except for your finger would kind of get tired after a while. So, so what I did over here is I built a transmitter that replaces the remote, and bought a nice microphone from Lady Ada here that runs on 5 volts and has a really nice amp built in. I think $5 for that, I can't remember. And then $1 for this exciting IR LED, and then you needed a little resistor. And then, according to Lady Ada, there's not enough voltage. By the way, this is a stem which has an Arduino built into it. So this is just it looks like I'm running it everything like magic on a breadboard, but there's actually a microprocessor inside there. And so I'm running C code on it from Arduino right now. And you can see that this thing is actually listening to us. And if we now point it at this guy here, you'll notice that it's just running all sorts of crazy codes against it right now.
Just random.
And, well, no, actually, it's supposed to be 1, 2, 3. It's supposed to be 100, 200, 300, 400, 500, 600, 700, and up to 1500. And it's not working. So there's something wrong on the C side of the universe here. So there's something wrong with the libraries or the hardware, or I have a wire in the wrong place. Yeah. Now, I have, by the way, I will tell you that I hate transistors when I work with them, and I made the same mistake as I always did. I put the transistor in backwards for the first 2, 3, 4 hours of this, because I always think the flat side is the front, it's the back, and I always forget, and so I'll spend hours trying to figure out why my transistors don't work. And I don't know if you remember your electronics, but if you have a transistor backwards, they do work strange and in unpredictable ways. And so I'm not too happy with that for the while. So this is not working because it is unable to send a clear code like this does. But I'll find another library and see if I can make it. But I've got the microphone working. I can read the microphone. I can send all the microphone signals into the Arduino. The Arduino can then is making 10 different signals based on what it's receiving. It's just sending them out as garbage to the gamma here. But we do have all that working. So this is the plan. Is if I could get the flame walkers to also be remote walkers.
Yes.
Yeah.
Or better yet, sync. Yeah, and see now this is about $25 of hardware, and we could put like 4 of these out, and you could cover the whole dance floor.
Okay.
Can we
What's
summarize-
range?
It's usually about 10 feet, maybe more. It depends on the set and the other thing.
Can we summarize the effect again then that you're trying for?
I just synchronize shoes.
Okay.
Or if and I don't care, it could be capes, whatever you want to.
Exactly.
Whatever you put the gamma on, run the code, and have it do that. So that was my,
Are we limited to the number of synchronized people?
and I don't think so.
Oh, wow.
So I
So
believe,
everybody, that'd be cool.
yeah,
It'd be like a flash mob.
the signals might get a little lost if there's too many people. So the other thing is we could also make people into relays. So we could put some of these as boxes around people's necks so they could be relays of sound
Oh,
also.
okay.
Because that's
Yeah.
nothing, or a vest.
Yeah, yeah,
That's nothing.
yeah. And these can come in very small sizes. I could make these out of a trinket and run these, on your wrist.
Yeah.
So anyway, so that was the idea, was synchronize all of the flame walkers.
Then
So,
we need a dance team name
oh, well, we'll come first. We need it working. So before we get it dancing,
now. Look what problem you caused now.
so I hope that was interesting. So that's almost working. I just cannot get the codes through. This morning I was working on it for 2 hours trying to get the codes. And eventually came to the conclusion that it sucks. That don't work. And so we will find some way. I've got other microphones and I've got other things to do. But you can see as we're talking, we actually, it's, even though it's pointing the wrong way, it's still bouncing off somewhere and hitting it. So this is pointed backwards and it's still running. So
how is this power right now? Is it
just USB.
So without it, do you get another source?
Yeah, it'd be 9-volt battery.
Oh, is it?
Yeah. Yeah, these run on 9 volts. They're easy to keep alive. Yeah, so 9-volt battery and that, or if you get these smaller ones, it even is more fun. So now let's move on to the other failure. All right, so back to the PowerPoint. This one here was our other failure, but it was close. And so this is our analog shoe design, which we talked about. And so what I have come up with is I've got, for just plain analog, I have a 9-volt battery running into a breadboard, and then I created 2 separate power structures in here. So if you notice, I have a regulator here that will take some of the voltage down to 3.3 volts.
Okay.
And that's because the microphone doesn't like lots of voltage. And so we don't want to fry this with 9 volts. Otherwise it'd be a former microphone. And we've also put the vibration switch in, and it is boring. And so we need some kind of, what I'm thinking of doing is that the vibration switch, barely even seen, you can barely see it. I'll try to think about either latching it so, stay on longer, so it'll go on, off, or, yeah.
Sorry, just very quickly, how do you calibrate that?
I haven't.
Oh, yeah, okay.
That's the challenge. It's just a vibration on-off switch. And so it just says it's a tin can with a spring in it.
Oh, okay.
Can you collaborate or calibrate?
What I'm going to do instead is what I think I want to do is instead have 2 sets of LEDs, and one set's always on, and just have it switch which ones are on.
So,
Yeah, because this is just an on-off switch.
On-off.
It's nothing interesting there. But so the other thing is I could buffer it or noise and try to change. But this is straight electronics. I don't have a easy way of doing that.
You don't have access to the flip-flop in the circuit.
I have flip-flops over in that box right over there.
Well, you can do that.
Yeah, so I have LS 74 LSs over there. So I've got a flip-flop right over there. And that'll be desperation if I go to that. All right. And so then the other thing that I wanted to do that isn't working is I put the pod in here instead. These little lights over here, I turn them up and down. What I wanted to do is I wanted them to be controlled by the mic so that we would have an equalizer effect again. And I haven't been able to get, this doesn't produce enough juice to drive an LED. So I'm going to need an amp for it, or I'll hook up a bunch of transistors and do it the old-fashioned way. Yeah, I've got some amps right in there. So this is the and so let's see if we can get the analog version running. And so this is the analog design as we discussed it. The can is boring. And but we do have the potential of getting equalizer running for it, and so
Could you put
we'll
that in a smaller container?
oh yeah, this is my mostly throw some wires in there, throw some LEDs in there, and see if I can make something look interesting. And the reason they're so bright is I think I went with 10 ohms, so they're burning up actually. But if you could. You're going to send me that bag right over there.
What's your build time? What's your build time so far?
Oh, I have no idea. And so if I need any more LEDs, I burn them up. I buy them in small sets from China.
How much is that like?
I don't even know. I think it was $10, I think, or something. Yeah. So if you need some LEDs, you just let me know. I've got. Yeah, help yourself. Have a handful. Yeah. So that's the demo of the where we are on the 3 shoes that we are designing, which are the out of the textbook, the Flame Walker, over here. And then the synchronizing LED, IR LED, and you can see it's still blinking because it's still hearing from the screwed up Arduino process. Every time we're talking, it's sending out signals. It's actually sending out different signals, but they're all shredded right now. And then our analog solution here, and we'll see if we can get anything that work there. So far we have, on the analog solution, we have 1 vibration detector, a pile of LEDs, a special blinking LED. The red one is the special blinking LED. That's what's causing all the LEDs to blink. And then we have some cheapo ones from China. And then we have the pod right now that is pretending to be the microphone, because I don't have it working. But that's the idea, is that we would have it going up and down with the sound. Or if we can get really cool, we'll amp the sound and then we'll filter it. And an amp is, we'll use an LM3 something. It's a little tiny chip. It gets 2 amps on the chip, so that's easy to do. I've done those before. So that's where we're at. So this is the, so far, how far we've gotten with the wild shoes. And we'll have some things. We have the metallic thread to sew in all of that. And we have some more NeoPixels if we want to decorate some other items. And we had few soldering disasters this time, but more software problems as the hardware over here doesn't work. So that's it.
Do you have any more on the slides?
That's it.
Okay.
I question. Oh, actually, I take it back.